Good morning to all. Myself, Arul Soumya, working as an assistant professor in Department of Computer Science and Engineering. Here, I'm going to discuss a topic on classification, how a loss function for the logistical model. So here is an introduction of logistic regression. That is, it's a supervised learning algorithm and it has used for binary classification problems. So output of this can be a probability value between 0 and 1, and it uses a sigmoid function to map predictions. So what is sigmoid function? So here the sigmoid function, which is a converts a linear output into a probability matrix. So how the data is formalized here means it produces the S-shaped curve, that is an output range value between 0 to 1. So this is the S curve. So this is called a sigmoid function, that is S-shaped curve. Here this graph shows the S curve. So this is the log loss curve. That is a binary cross entropy. That is, we can get a loss and predicted probability by using this graph. So this is the problems with mean squared error. So here the problems with mean square error means it is a linear regression and it is not suitable for logistic regression. And it produces non-convex and optimization problem. So here it makes a gradient descent in a difficult way. So real life example, that is a log loss example. So how loss changes with predictions. Here we are having actual predicted log loss formula and loss values here. So using these values, we can get what are all the data are in low loss and what are all the data in high loss. So applications of logistic regression. So application in the sense it has a credit scoring and medical diagnosis and customer churn predictions and spam email deductions. So logistic regressions is a statistical method that we can use how the classification problem. So especially when the outcome is binary, like a yes or no, spam or not spam, or disease or not disease. Like we have an unlike linear regression, like which we predicts continuous values. Logistic regressions predicts the probability that an input belongs to a particular class, that it does this using a function called a sigmoid function, which maps any value into a range between 0 and 1. So the model here, it takes a input features, like it multiples them by weights by adding a bias and passes the results, and through the sigmoid function the output can be predicted as a probability. So if it is above a threshold, like a typically a zero point 0.5, then the model predicts one class. Otherwise, the other one mathematically shows how the log odds of the probability, so which it makes it for a suitable for classification tasks. So how we are training the model here? So here we training the model by involving finding the best weights and minimize the loss function called log loss or cross entropy loss. Here this is usually done using optimization techniques like gradient descent. So eventually the logistic regression is popular, like it because it is a simple, fast and interpredictable. So we can understand how each features influences the outcome by looking at the model coefficients. So however, it seems a linear relation between input features and the log odds. So it can perform well on complex or non-linear data without feature engineering. So here we can get a logistic regression by using the log loss or a binary classification. Like a log loss ensures a convex optimization and it penalizes a wrong confident predictions heavily. And here the data is optimized using a gradient descent. So using this logistic regression, the interpredictable, like we can get the feature influences by getting the model coefficients in a log loss of binary classifications. So eventually, we can train the models by involving the suitable classification tasks and finding the best weights, and that minimize the loss function, which may be called as log loss or cross entropy loss. So, however, it assumes that logistic regression is a foundational classification algorithm, and that balances simplicity, interpretability, and effectiveness. Thank you.